And you have the two types, Senophora and Arabica, basically. Arabica is the expensive one. That's the one that has that nice coffee smell. So when you go into a place and you smell coffee cooking, that's Arabica. If it's Senophora, you probably don't notice it as obvious because it's the cheaper brand of coffee. And some places blend them together, so you get a blended mix of the two. The more Arabica you put in it, the more expensive it is. So you go in Starbucks, it's Arabica coffee, because you can smell that even before you get to the store. You can smell it out in the street. They're doing that Arabica coffee. And in the 1800s, coffee rust came to Africa. There were no resistant varieties. There were no fungicides. Coffee rust goes rampant through Africa and kills the coffee plant. Everybody turns to tea, and the British make tea famous. You can go and have the Queen's cup of tea in the afternoon. Every afternoon you would have a cup of tea. And now I see, what's that doctor guy that's on TV? Oz, yes. And he was on yesterday, and he was talking about everybody should have a something with warm water in it to get your digestive enzymes working. You shouldn't be drinking ice water. We shouldn't be drinking ice drinks. We should be drinking a warm drink with water in it, and that gets your enzymes working. Well, the British have this every afternoon. They drink tea. And I saw an ad yesterday, too, for an auction in St. Catharines, and somebody was auctioning off a tea caddy. The little wooden box that tea came in, it was all leaves. And you would tear up little leaves from different tea plants, blend them together, and make your guest a personal cup of tea. Personal for them, that you made yourself, not tea bags and the way it is today. You would blend it up. You would chip off a piece of sugar off a big obelisk, which is like a thing that pyramids look like, a giant pyramid. You would chip off a piece of sugar and then lock the sugar up because it was the most valuable thing there. You'd lock it up in a cupboard, and then you didn't give them necessarily cream and milk because it could be spoiled. It could spoil on you. And everybody went for tea for years and years and years. Queen Victoria, that was a big thing. Now we come to coffee growing in South America, and coffee moves there. It has a resurgence, and we see coffee make a big comeback. Everybody wanting coffee. And then coffee rust comes to South America and starts to wipe out coffee plants there. And everybody turns to Coca-Cola and all the pops. We see ginger ale, Coke. Root beer is a famous pop here in Canada. It's made from the root of a tree. It's here in Niagara.
We used to chew on those as kids.
Yes, and it has the flavor of root beer in the bark when you chew on it. You can taste the root beer on it. Today, they're all made synthetically. They're not made the original way, but people turn to pop. We have a whole generation of the 70s on pop, all different kinds of pop. Then coffee moves to places like Jamaica and the islands, the mountain areas, and coffee makes a comeback again. And now we've got Starbucks, and we've got, Tim Hortons and all these places where you can get a nice cup of coffee. If coffee rust, and we've got resistant coffee plants. We've got fungicides, just like we have for wheat rust. And coffee has made a big comeback again. But if coffee rust ever mutates or adapts to these new varieties and gets these enzymes going, will coffee take another turn down into the toilet? The price of coffee will go up over $6 or $10 a cup, and you'll all say, geez, I can't afford $10 a cup. That's a lot for a cup of coffee. I'm going to buy... Yeah, I'm going to buy... Yeah, it's almost there now, right? I'm going to buy... And there's a question mark. What is it that you're going to buy? And the companies are all searching for, is it colored water with a little raspberry flavoring in it or strawberry? Is it monster drinks? You buy these monster drinks that full of lots of sugar and
We like
hype you up.
options nowadays. We like options.
Yeah, you got some options. Is it green tea?
Orange.
Because all the older people want tea again. And the green tea is in, bubble tea, is it, which kind of tea is it? Flavored tea. And the coffee companies, when you go into Tim Hortons, they've got lemonade, pink and white lemonade. They're trying little experiments to see whether you'll buy an alternative to the coffee and tea that's offered. You might mocha java latte, coffee mint flavored.
Coors Light iced tea.
Oh yeah, everything. Ginger ale with iced tea in it, with green tea in it.
Iced cappuccino.
Yep. So which one is going to be the next big one? They don't quite know, but they're all hinting at something in case. Because nobody wants to be the owners of a Tim Hortons or Starbucks and find out that nobody's going to show up to buy a cup of coffee. They just had a thing on television the other day to find out where the most expensive cup of Starbucks coffee is. Because they're different prices. It turned out it was China.
Really?
China has the most expensive Starbucks coffee, probably because it costs a lot to set up a Starbucks store there and haul that all that way. The cheapest place was India because it's growing there, along with a lot of the tea is growing in India, so they don't have to ship it very far to get it to the Starbucks in India. And so it was $1 something for whatever size they were looking at. It was $3 something in the United States and $3 something in Canada, something like that, just under $4 a cup. And it was $1 something in India. Once you converted the money into American money, it was like $1 something. So they had the cheapest one. Another place with really expensive coffee was London, England. And they didn't really have a lot of explanation why it was expensive there, but it is. Probably because they want everybody to buy tea. And, you know, the tea guys are lobbying for the importation of coffee, put the price high, and then we can sell tea. So, any rust disease that you pick will look like these two here. And so now you should have, and everybody should check to make sure they got the two handouts, you should have two oomycetes, which is the late blight of potato. Should have the late blight of potato, and you should have downy mildew. Those are the two oomycetes. You should have two ascomycetes, which are the apple scab and brown rot of stone fruit that's going around here. You can take a photo of that if you want. And the two basidiomycetes, which are wheat rust and cedar apple rust, the one that we saw at the cemetery. Those are the two basidiomycetes. Just a little review of test stuff, just for a few minutes here. We'll do that as well here. And in this case, the reason I gave you two of each is because that if I give you another unknown one, I'll take a pair of scissors and cut off the title at the bottom with the name of the disease. And then I don't want you to give me the name of the disease, just want you to look at the cycle and say which group of these three it belongs to. So you have a 1 in 3 chance of getting it right. If it's an oomycete, it's going to have zoospores. If it's an ascomycete, it's going to have a bag with 4 spores in it called an ascus. And the little spores will be called ascospores. And that will be an ascomycete. And the third group today is basidiomycetes. And this mycete group is going to have the 5 stages, but the last stage has club-shaped structures coming out of it, out of whatever the shape is. And it'll have 4 little spores, and it'll be labeled a basidium, or basidia is 2 or more, and basidiospores. So now, when you go to a grower's talk anywhere, doesn't matter whether it's greenhouse or whether it's outside plants or inside, whether it's in South America for coffee, they will take the life cycle and give it to you, and you'll look at it, you'll see one of these 3 things on it 90–95% of the time, and then you'll be able to say, oh yeah, that's, if it was coffee rust, you'd be able to say, oh yeah, that's a basidiomycete. And you type it in on your internet, and there's the list of all the basidiomycetes, or a textbook, you open it up, and there's all of them there. And now you'll be able to find the life story of it, and how it's controlled, etc. And then I've done my job there. You now recognize the 3 most common groups of funguses. And the oomycetes swim in water, so they need the correct water. These blow by air, at least for the asexual. And this one moves between 2 hosts. There's 2 hosts usually. Not always, but usually. Okay? So that is the funguses. Just so that you have this, and I don't know whether I mentioned this or not, but fungicides fungicides for any fungus, doesn't matter which group it is, we have things that are preventative. You put them on before the fungus gets there. So right now, the golf courses are spraying fungicide for pink and gray snow mold. It isn't here yet. It won't be here till spring, but you've got to put the stuff on now so that you don't get the disease. And so snow mold is one that's a preventative one. We have fungicides that burn. They're called eradicants. So they burn the fungus off once it's there. The fungus gets there, you see the fungus, you apply this fungicide, and it kills the fungus by burning it. Burns the fungus that is there. And the chemicals that we use on powdery mildew, once you see it there, you can kill it by spraying it with a eradicant. And then we have what are called chemotherapeutants. Or systemics. And these are fungicides that you inject, or they soak up into the plant, and they go inside the plant, and then if the fungus goes in the plant, it kills it from the inside out. So that these aren't exposed to rain, and they aren't exposed to people touching them. They're inside the plant. And if you want to know something about them, you can look them up in the dictionary. There's a dictionary for products, or call them up on the internet. They'll tell you whether the fungicide goes up only, or down only, or up and down. So it's up only, down only, or up and down. It doesn't matter. And so we've got systemics that work either way. The ones that go up only are probably a drench that you pour on with a watering can into pots in the greenhouse. And then once they soak into the soil, they go up by root and protect the plant. The ones that go down only, you just spray along the top of the plant. You'll have a little sprayer that travels over the crops in the greenhouse and sprays down on the tips of them. And then it connects with the tips and then goes down only. If it goes up or down, it doesn't matter. You can just spray the plant anywhere on its body, and then stuff goes up and down. And so some of them are one way only. So you have to kind of know before you apply them. And disease like Dutch elm disease, they're trying to control it with systemic products. It's about almost $3,000 a tree for one treatment. And you inject it into the root system, and then it goes up inside the tree and protects against the fungus. They've had limited success with it, but they're still doing Ottawa, the Parliament buildings, because that's the only tree around the Parliament buildings is elm, and they don't want to see them die and have to replace all the trees in Ottawa with brand new trees. It looks so nice there. So they spend the $3,000 every year and give them an injection of systemic fungicide. Benamil is the most famous systemic, or Ben Lake. Benamil is the most famous systemic fungicide made. We don't see it used too much anymore. A lot of funguses are getting resistant to it, so we have to use one of the new ones on it. Same thing could happen to you. You could get some fungus disease that requires a spray and eradicant once you see the fungus, or maybe you'll get an injection from the doctor that's systemic, or you'll take medicine that you drink, goes inside you and travels through your body and kills the fungus. If it has myosin on it, then it's a bacteria. So we know the difference. When you look at your medicine that the doctor gave you, you'll know if it's a bacteria or if it's a fungus that you're trying to fight off. Viruses, there's not a lot of medicine that controls viruses. They'll try giving you antibacterial medicine and stuff, hoping it's going to lessen some of the effects. But viruses are tough to control. So we'll come to viruses a little bit later. So for the test, next week we have bacteria, fungus, and some ID samples. I'll try and do most of the IDs as fungus diseases. I'll bring around that little peach pit there. That's the one for, I'll try and send some around to you. You've got black knot. We've got that little brown rotten stone fruit that's going around there. You can take photos of those. And so just to go back for a minute, just to bacteria, and I'll just run through a little quickie review thing here. You've got it on your notes, and you've got it on Blackboard. Bacteria start out with the small size of them. 1 gram, that's like a Smartie, could hold 1 million bacteria. They're very tiny, and there's a lot of them, especially in soil. So if you've got cuts on your hands or feet or legs or arms, and you work in soil, you should be careful, because they'll enter through those cuts and you could end up with an infection, bacterial infection. How do we ID bacteria? There's 5 or 6 ways. The main one is to take a picture of them, and they come in different shapes. They come in rod shape, they come in round or spiral. So rod is plants, round is people, and spiral is animals. And usually they do not mix, except for rabies. That a rabbit dog bites you, you could get rabies. So we know instantly, just by the shape of them, which group they belong to. Then if they're plant ones, the flagella or tails on them, you count the number or the position of the tails, and that tells you which disease it is. So they simply look under the microscope and count how many little tails there are and where those tails are, and then that tells you what the bacterial disease is. The third thing is they all produce gas. Bacteria give off gas. And you can tell by the gas which bacteria it is. Right now in the Philippines, there's thousands and thousands of people dead. It's a horrible disaster. And there are people dead all over the street, and they don't have anywhere to put these people.
Yeah,
They don't even have.
They need like a bunch of coffins.
Yeah, they need coffins, they need body bags, they need a place to bury these people because bacteria get on them, and you'll recognize that smell because bacteria give off gases.
Send them to Russia.
And unless you're frozen, you will smell that. It'll be a horrible smell. It also could transfer to people getting close to those bodies. So, you can smell it in milk that's spoiled. And a lot of the diseases that are on plants, you'll recognize that smell. So if you beat up a vegetable and put it in your fridge, you'll smell that horrible smell. And it's sulfur, it's ammonia, it's one of the gases that's given off. And so we can tell which bacteria it is. The next thing is stains. We put a stain on them and turn them colored. And they're either gram-positive or gram-negative. Most plant ones are gram-negative. The bacteria is clear. You can see right through them. And the background is pink or purple or some shade. There are a few rare solid colored gram-positive ones that the bacteria is colored purple or pink and the background looks like water. But they're rare. And so most plant ones are gram-negative in style. What else can we look at in there? We've got the host that they grow on. Sometimes you just know because it's crown gall. We know that's a bacteria because they've done a whole bunch of research on it. Fire blight of mountain ash. And so those are the things that we do to ID a bacteria. Then we want to know, once we've got the bacteria ID, what kind of symptoms are there? There's 6 symptoms. And you've got those: rots, spots, wilts, blights, galls, canker. 6. Rots, spots, wilts, blights, galls, and canker. You've got 5 Latin names. And I know there's no other way than just to memorize them. That is because if you get asked for a job or you go for a job interview, they're going to ask you to name a disease in Latin. If you only have 5 to remember, hopefully you can think of one of those 5. I tried to pick easy ones that had an easier Latin name, and 2 of the symptoms have the same Latin name: Erwinia amyloid or fire blight. So you can list the symptoms and give me a Latin name. Causal agent is the same thing as a Latin name. They try and confuse you. Can you name me a causal agent? That means can you give me a Latin name? And so every disease has a Latin name. You'll have 5. Even though I gave you some today, you don't have to repeat these. Those 5, yes, I'll ask you to repeat those. And that's so that you can apply for a job and answer that question. It's the very first question they always ask you. Can you name me something in a Latin name? They want to see if you know anything about Latin names. So we'll do those. What else is in the bacteria? You'll talk about maybe controlling the bacteria. It's listed down there, some ways you could do that. Sterilizing your equipment is one of them. It's a very good way of getting rid of bacteria. Some of you will take antibiotics. And for people, my son just got a dose of them. And I'm looking at them in the fridge and figuring, oh, it was some other one that I hadn't mentioned. It was another myosin. And I'm thinking, oh yeah, he's got some kind of bacterial thing, throat infection. They make you take this. We could use it on plants, but plants are expensive because it costs a lot to cover them. And you have to cover them. He has to take his 2 with each meal. Well, you'd have to put 2 treatments on every day. And that would be expensive to do. And if it rained, you'd have to put another one on after it finished raining. So watch out for that. So you've got some controls there. And then I think we went to the funguses, and we had oomycetes, like I said, and that has zoospores. You might be able to list an oomycete disease. And I might ask you questions about the two diseases that we did. So we did two famous ones, late blighted potato, which is the potato famine in Ireland, and things like how would it spread. Well, it spreads from the cull pile, it blows over by asexual spores, or you planted it by taking little potatoes and cutting them up and planting infected potatoes, and instantly you got it. It was an old phrase in Ireland. My wife's from Belfast, Northern Ireland. It was an old phrase that, how does it go? All the good men are taken, only the cull, all the good men are married, only the culls are left. And that was a phrase they had in Ireland. They threw the potatoes in a pile, and that was the cull pile, and that's where it germinated and had sex, and all those spores blew over onto your healthy potatoes. So, yes. They had other phrases that I shan't repeat. I got to be careful. My wife will get me in the Irish headlock. Anybody know what that is? She comes up to you, and girls in Ireland all know this one. They come up to you and then they say your shoe, oh look, your shoe's untied. And when you bend over to look down at your shoe, they get you in the headlock. And they got you in the headlock, and then they hit you with the free hand. So, that's how they do it. Yeah. Oh look, your shoe's untied. And then you're in the headlock, and they're wailing away on you before you know it. So, the ascomycetes, and you've got two of those. I'll ask you, can you name me an ascomycete disease or two? Those are the ones that I gave you. Use them. And I might ask you some questions about the life cycle of those. How would you recognize a sexual or asexual spore in this? And so you could tell me in the ascomycetes, on the sexual side, the male and the female mate, and then they form a structure. You can tell by the structure, and you can tell by the spores. Apple scab spores look like little footprints. So I'll probably ask you something like that. And then you collect these little spores, and then you can tell that that disease is in your orchard. And then the last one here, we've gone over some of these. Now I didn't do smuts and mushrooms. One thing that I should say, I guess, about smuts, there really isn't a smut disease that attacks trees. They're all agricultural ones. Maybe later I can, if we've got some time, I'll run through one of those with you after the test, but it won't be on the test. And mushrooms, there's a lot of good funguses in this group of basidiomycetes. In fact, most of them in here are good things. And the mushrooms that you put on pizzas, if you had the little mushroom cap, the top of the mushroom, and you look at the mushroom growing there, there's little gills inside the mushroom cap. In Ontario here, we sell mushrooms as button mushrooms and closed mushrooms. They're all closed up so you can't see the gills, usually, unless you buy shiitake and those bigger, fancier ones. They're open. In Quebec, they sell their mushrooms open. They don't sell the little button ones. They're sold as an open mushroom where you can see the gills. It's just an oddity that happens here. And if you took a little cookie cutter and cut a piece out of here, or set this on a piece of paper, you would get like a pattern of all the gills. Because in the gill here, you take the gill, inside here, there's a little clubs that come off the gills. And on these clubs are 4 little spores, 2 pluses and 2 minuses. And that's what makes it a basidiomycete. And if you cut the top off of this and set it on a piece of paper, we used to do this with kids, you got a little pattern on the paper. That was all the spores coming off and made that little pattern of the gills. But that's where they're located inside here. At the mushroom farms, if any of you get a job at the research station, sometimes they assign you to the mushroom area first. It's an entry-level job at the research place. And the companies that produce the mushroom spores, they take a cookie cutter, it's a hollow tube, and they jab it in the cap here, down into the gill area. It's a little hollow tube. And they take these spores out of it. They put the spores in a test tube with water and a grain like rye. And then these little spores germinate, and they send out the mycelium onto the rye seed. And then you drain all the water off, and you put this seed that's covered with mycelium into a bigger container, like a beaker, and it germinates on more seed. And then you move it to a large pail, and then finally you pour this pail of fungi into a giant drum, like a place that makes beer, giant vat, and it's got seeds in it. And then this mycelium grows all through the seeds in there. And then they dry it out. They take the water all off of it. It's dried, and it's packaged in 1 liter containers like milk. And that's what you buy to seed down your mushroom house. And you'll have your little mushroom house. It'll be a room like this with no windows. It'll have lights in it because they want to see to do the harvest. And there'll be movable trays now. They're modernized, like this, only bigger, like a movable tray. And there'll be aluminum trays on each level. You fill them with artificial medium, and then you sprinkle these seeds on top. Put them in the room, turn the lights out. The mycelium grows all over the whole medium. And then once it's covered and all fuzzy looking, you cover it with a thin layer of either soil or peat moss. And it's like pulling the blankets up over them. And then they have sex. The mushrooms have sex underneath that little blanket. And then the mushrooms poke up. These are the offspring. They poke up through this. And then you take a little sharp knife like we use here in floral design, and you cut off the mushrooms before they open, and they're graded and packed and sold at the store. In the end, they used to sell little mushroom kits to kids. You could go in and buy the last flush. The mushrooms come in flushes. Every 7 to 10 days, the next crop comes up, and you cut them off. Every crop that comes up is smaller than the previous one. And finally, there's hardly any mushrooms. They cut out sections, and they used to sell it to kids at hobby stores and places. You could buy your little mushroom kit, take it home in a little tray, and put it in your basement, give it a little water and the right temperature, and voila, a mushroom would come up. Yeah, you can still buy them. You don't get very many mushrooms. You pay $10.95 for it or $14.95, and you get 2 or 3 mushrooms, and that's it. The next flush, there'll be 1 mushroom. Got 3 in that one and 1 in the last one. But it's the thrill of growing something, right? And seeing how it grows.
Thrill on the smell.
Yeah, thrill in the smell. So a lot of people now are growing the bigger mushrooms in their garages. You don't need sterile conditions, and you don't need as stringent stuff. If you go to the mushroom companies that make mushrooms, they're made by people like Lever Brothers. They make toothpaste, Crest. They make a bunch of products, cleaning products. They also control almost all the mushrooms in Canada, commercial ones. And you go in on the tour, they make you wear a white lab coat. They show you everything through a window that is soundproof, because they don't want people to take this in the lab. The mushroom that they're using is a special mushroom. It came out of the field outside here. It's a meadow mushroom. But they've bred it to be white, absolutely pure white. And they don't want you taking the spores or a mushroom home and getting access to their original mushrooms that they take the cookie cutters out of. You'll go in, they'll take you on a very nice tour. They won't tell you the exact temperature. They won't tell you the exact mix of stuff. They just in general give you the stories, and they're a very nice story. And at the end, you see them harvested, and then they sell them. Very interesting. We only produce 40–50% of the mushrooms that we need for the fresh market here in Canada. All the rest of the mushrooms that we buy come from the United States, or they're canned mushrooms from the Orient, from China usually. We get canned mushrooms. They're all foreign mushrooms that come in canned. All the fresh ones are Canadian mushrooms, but we don't produce enough to warrant it. They're going to give you this job in the research station. This will be like an entry-level job. The only thing I can tell you is, please don't jump in the doorway. When you come through the door, there'll be a tray in the floor, and it'll look wet. It's got liquid in it. That is to sterilize your shoes. So when you walk in the room, you're supposed to step in the tray with both feet, and the liquid kills any funguses on your shoes, so that when you walk into the area, you're clean. I see people trying to jump over the tray, and the floor is wet, because after you get your shoes wet, you step out of the tray, and it takes a few steps before it drips off. Well, you jump over the tray, you hit the floor, and you fall, because it's wet. And then you hit your head in the tray. And then everybody's laughing and all pointing at you. And thinking, oh my God, what the hell have I done here? I'm almost so stupid. I jumped over the sterilizing tray. And they'll make you wear disposable clothing, probably. You'll come into an area, take your clothes off in the dressing room, and put disposable white clothing on. That's so you don't spread any diseases. Mushrooms get diseases. They get fungus diseases, insect diseases, bacterial diseases on a fungus. And you think, how can that be? But that's true. And so they don't want any of this in the mushroom growing area. And then you get the nice fresh mushrooms. They used to do it on horse shit. I think that's why it's an entry-level job at the research station, because in the old days it did smell pretty bad. Today it's all artificial, and it doesn't smell bad. It's like a cafeteria. Everybody's wearing sterile outfits, and they're using little rolling trays, aluminum trays and stuff. The old days it was always wood. Okay, how many people still here don't have enough samples? We've got some people with not enough samples. Okay, so most of you have your samples. What you want to do is get started. The people that have their samples will get started on your stuff. Make sure that you do an index. I think I went over this last week, so I'll just mention it one more time. You want an index with everything listed, the numbers, and I gave a sheet out with it on twice now. You're going to have it divided into diseases, insects, and physiology. And so you put a little title slide with each one, and then the ones that belong in that group. Number them. Put your name on the collection at the start. You know, you got an intro slide with the title of the project. Put your name there. Put your name in tape on the outside of your disc or the outside of your stick, so that when I give them back to you, there's 90-something people in this class. It's a lot of people. And everybody thinks, oh, I got the only blue one. There's 43 blue ones sitting there. You have to keep plugging them into a computer to find out which blue one is your blue one, because they're all the same blue. So, you know, somebody will give me an interesting looking Yoda or some kind of weird little animal, and you'll know for sure that's yours. But if it's just a regular stick and it's yellow, it's blue, it's black, there'll be like 40 of the same thing. So put your name on it so that you'll be able to find it. Show it to me if it's not. If you think you've got questions and it doesn't look, you know, like you maybe got some mistakes, show it to me. This is your chance to get a really good mark on this part. Hand it in to me when it's all done. The first week of December I should get them, because the week of December the 13th is exam. And so I need them done by the next Wednesday. I've got to give the marks in by then, so don't leave them until the very end. It just makes it difficult for me to get the mark. I will give them all back to you. I have you all next term for something. And so you'll get them back then. And I mark each slide on a 6. So it's 2 for the One for the genus, one for the species of the plant, one for the English name of the plant, 2 for the name of the disease, English, and 1 for telling me the location and the date that you collected it. Those things, that should be easy. Then I have marks for organizing it, so you've got it organized with the dividers and the index. You get some marks for that. Everybody's collection will be out of something different unless you have exactly the same number of samples as somebody else. And yeah, you guys will be the same. So then yours will be out of the same. And it'll be then transferred to something out of 25. Okay. And so the test next week is out of 25. The collection is out of 25. The first test was out of 25. And the last one will be out of 25.
I had a question about the review.
Yes.
For the bacterial, the shape for the human bacteria, you said it was circular.
It's round, yes.
But what about E. coli? They're rod shapes.
Well, there's always exceptions.
Okay, so it's just.
Yeah, it's a general thing. 99% of them are round.
Oh, okay.
But well, I'm trying to simplify it so we don't have too many
Oh, okay.
overlaps. But yes, there are. There are E. coli that are round too.
Yeah, there are some. Yeah.
Yes, and so, but the majority of human ones are round. And, but there are exceptions, and I tried to give you one example of, you give me another one, but of rabies that attacks people, and it's not round or rectangular, it's spiral.
Yes,
And
there's
so-
spiral bacteria.
Yeah, and so, you know, you can say all you want that, well, it's always this, but always is a bad word to use. So, what we'll do is, I think, rather than going so all the way to Vineland, we'll just go. How many have to go with me? Is there 1, 2, 3, 4, 3, 4,
Video.
5? Okay. Let's go over to the old Hort School. It's closer on Niagara Street. We'll stop there. I'll show you 6 or 7 things. What do we need mostly? Is it insects or diseases? Or?
I think we need another, what's the factor? Abiotic? Yeah, we need more insects.
Insects. Okay. Well, let's go to the Hort School there in Niagara. It's not very far away. You can get there quick.